Hello everyone. Now we will continue our learning on rock properties. Previously we have learned about porosity and now we will talk about permeability. Okay, permeability or with the symbol K by definition is a measure of the ability of a rock to allow fluid to flow through it. The unit is in millidarcies or darcies. Most commercial reservoirs have permeability ranging from 20 millidarcies to 500 millidarcies, where tight reservoir has permeability of zero point 0.1 to around 1 millidarcy. Okay, and here is another classification. Permeability below 1 millidarcy, we call it poor reservoir or poor rock. 1 to 10, fair. 10 to 50 millidarcies, moderate. 50 to 250 millidarcies, good. Good reservoir, good rock, good property. And 250 millidarcies or more than more than 250 millidarcies, we call it very good rock, very good permeability. Okay, permeability based on the lithology. As you can see here, we have three type of rocks. Okay, yeah, the first one is shale, the silt, and the sand. And based on the picture, you can distinguish, you can differentiate, you can tell that shale will have the lowest permeability, and then the silt, and then sandstone will have the highest permeability. Okay, because by definition, permeability is a measure of ability of a rock to allow fluid to flow through it. So as you can see in sand, if we zoom in, here the white area, white zone is the space through which fluid can flow. And you can see this white zone, we can call it roughly the permeability or the connected porosity. And we have many channels here. But here it is very tight. The channel, the permeability or the space that enable the rock to flow fluid is very, very small. So shale will have very low permeability, but sandstone can have high permeability. And then based on theoretical experimentation, we can get permeability using this experimentation. This was done originally by Mr. Darcy, from whom the unit millidarcy, we get the unit millidarcy. So Mr. Darcy conducted this experimentation. He has this connected pipe, the first one with the reservoir in the right side and then the left side. And he made this pipe to be like this with distance between the surface on the right storage or right tank and the left tank. There is a distance, and we can convert the distance to delta pressure, okay, because they are connected. And this is the area of the pipe, okay, area of the pipe. And here we can put a core or rock with length of L. And from the right tank, we flow fluid, for example, maybe water with viscosity that we know. And then we measure the flow rate here. And based on this experimentation, Mr. Darcy concluded this formula. So delta P divided by L, the length of the core, is minus 887.2 multiplied by the flow rate Q and the viscosity of the fluid divided by something multiplied by the area. And this something is actually the permeability. Okay, using this experimentation, he obtained a linear pressure gradient. So P input here, the input, and P output here, and P in minus P out, we get delta P, and this is the length from length 0.0 to L. So the total length is L, and he get this linear pressure gradient, okay, with this flow configuration, this linear flow. So again, this experimentation or this correlation can be obtained, can be generated with this term permeability. Okay,